قابلنا التحدي في مدرسة الحسام، أسسنا منهج علمي يبقى لهم دليل، بنواجه الأزمات بتاعت ومش كلام، ونجيب لكل المشكلات حل وبديل، علشان إيماننا بربنا وحب في بلدنا، قدمنا ليكم علمنا علشان ولادنا، عهدك علينا مصرنا لما تعهدنا، توصل رسالة علمنا لكل جيل في مدارس الحسام.
Good morning, my dear students. Let's continue our speaking in chapter 2, chemistry. Mr. Usama with you. Elements of P block. As we studied before the elements of S block, we took an example of these elements, group 1A, which includes lithium, sodium, potassium, rubidium, and cesium. Francium is a radioactive element, so we excluded it in our study. Elements of P block. As we know, a P block starts from group 3A, passing through 4A, 5A, 6A, 7A, and group 0 in the periodic table. We will take an example of P block, the group 5A or group 15. Elements of group 5A includes nitrogen, phosphorus, arsenic, antimony, and bismuth. The symbol of these elements: nitrogen N with atomic number 7, phosphorus P with atomic number 15, arsenic AS with atomic number 33, antimony SB with atomic number 51, bismuth Bi with atomic number 83. The electron configuration, as we see here, nitrogen ends with 2s2, 2p3, phosphorus 3s2, 3p3. That's why nitrogen present in period 2, phosphorus in period 3, arsenic in period 4, antimony period 5, bismuth period 6. As we note that here, all of these elements ends with P3. There are 3 electrons in the outermost sublevel, P. By adding these 3 electrons with 2 electrons, we can conclude the number of group, which is 5A group. About abundance of these elements of group 5A in nature, the most abundant element of this group is nitrogen. As we know before, that nitrogen exists in atmospheric air in percent of 87 or about 80%. 78% or about 80% in atmospheric air. The 4/5 of air volume is nitrogen gas. The other elements of group 5A, like phosphorus, arsenic, antimony, bismuth, exists in nature but in low amounts. The phosphorus exists in nature, the most abundant in earth crust, rather than arsenic, antimony, bismuth. They have the lowest percentage. The phosphorus appears in earth crust as calcium phosphate and apatite. Apatite forms from calcium fluoride and calcium phosphate compound, combination of those both compounds. Also, the presence of in nature of these elements is not pure. These elements occurs in nature in a compound like calcium phosphate and apatite. We will study the general properties of group 5A elements. The first property, graduation of the metallic and non-metallic property. The second one, different numbers of molecular atoms of each element. The third one, several oxidation numbers. The fourth one, several allotropic forms. The fifth one, oxides of group 5A elements, hydrides of group 5A elements, the last one. Let's start with the first property, the graduation of the metallic and non-metallic property. Starting with nitrogen, the nitrogen and phosphorus considered as non-metal as we know before. Nitrogen is a gas non-metal, phosphorus is a solid non-metal. As going down, the arsenic and antimony considered as metalloid. Metalloid, these compounds have the properties of metals and non-metals in the same time, called metalloids. Going further down, looking for bismuth, bismuth has a metallic property. Although bismuth has metallic property, it has bad conduction of electricity. Its ability to conduct electricity is weak. The second property, the different numbers of molecular atoms of group 5A elements. The nitrogen exists in nature, in atmospheric air, in form of 2 atoms molecule, N2, as we know. Phosphorus, arsenic, and antimony exists as 4 atoms molecule, tetraatomic molecule, P4, AS4, SB4. Bismuth, although it is a metal, it exists as diatomic. It forms a metallic crystal lattice and its vapor consists of diatomic molecules. These are the different forms of molecules of these elements in group 5A. Give reason, although bismuth is a metal, it has different properties than that of other metals. Why? Because of its low electric conductivity, as we mentioned before, and it has a diatomic structure. As we know, any metal has monoatomic structure like sodium, potassium, lithium, calcium, magnesium, and so on. But bismuth is the only metal that has diatomic structure in its vapor state. Whereas other metals are good conductors and they have monoatomic structure. So bismuth is considered a metal, but it has different properties than other of other metals. The third property is of several oxidation numbers. We will study the nitrogen behavior in its compound. Nitrogen has several compounds and it is a most important element in a biological organisms. Nitrogen available in ammonia, hydrazine, hydroxylamine, nitrogen gas, nitrous oxide, nitric oxide, nitrogen trioxide, nitrogen dioxide, nitrogen pentoxide. Each compound of these, nitrogen has different oxidation number in each compound. Let's take how can we calculate the oxidation number. As we know, the calculation of oxidation number from last term, here hydrogen has positive 1 valency, N combined with 3 hydrogen ions or 3 hydrogen atoms. Each hydrogen contains positive 1, so nitrogen carries negative 3. So the oxidation number of nitrogen is negative 3 here. Hydrazine N2H4, by calculating the oxidation number, we will find that nitrogen carries negative 2 valency. Hydrogen positive 1 multiplied 4 equal positive 4. So N2 must be negative 4. By dividing negative 4 divided 2 nitrogen atoms, we will find that the nitrogen has negative 2. Hydroxylamine, here by calculating the valency of nitrogen here, we will find that nitrogen carries negative 1. Nitrogen gas, the valency would be 0. As we know, any element, the valency of this element is 0. Nitrous oxide N2O, as we know that oxygen has -2, oxidation number of oxygen equal -2. By calculating the oxidation number of nitrogen here, -2 of oxygen equal to +2 of nitrogen, but we have 2 nitrogen atoms, +2 divided 2 equal +1. In nitric acid, NO or N2O2, here the valency or the oxidation number of nitrogen equal to the oxygen. Oxygen -2, so nitrogen +2. Nitrogen trioxide, N2O3. By calculation of the oxidation number in nitrogen in this compound, we will find that nitrogen has +3 valency. In nitrogen dioxide, NO2, O has -2, -2 by 2 equal -4, so nitrogen must be equal to +4. Nitrogen in nitrogen pentoxide, we will find that nitrogen has +5. So nitrogen has several oxidation number in many compounds, and this is the characteristic of the valencies or oxidation number of this group. The oxidation number of nitrogen in the oxygenated compounds are positive, while in the hydrogenated compounds are negative, as we noted here before. When N comes with hydrogen, N carries negative charge. But when N comes with oxygen, the nitrogen carries positive charge. The final item we will study today, several allotropic forms. What is the meaning of allotropy? It is the presence of the element in more than one form with different physical properties and similar chemical properties. Let's take an example. Phosphorus here exists in several forms. White waxy material, maybe red material, maybe violet material. As we know before that phosphorus is solid, arsenic solid, antimony solid. The several allotropic forms is a characteristic property for a solid nonmetals only. Solid nonmetals only. So nitrogen has no allotropic forms because nitrogen is a gas. Also bismuth has no allotropic forms because bismuth is metal, solid metal. Otherwise, phosphorus, arsenic, and antimony, they are solid nonmetals. So they has allotropic property. Arsenic here exists as black, gray, yellow, waxy yellow, maybe. These forms exist in nature. Antimony also exists as yellow or black substance. Thank you very much for listening, and I hope you with a successful studies. Goodbye.